All right, so now today we are going to go over something very simple. It's just about graphing square root functions, which we kind of hinted a couple of days ago. The drawing of square root function is very similar to the drawing of the x square function. So if you think about x squared, you have this the pair of axes. No. And then you go ahead and draw the parabola, right? So we said that you go to the right one, up 1, right one, up 3, right one, up 5, and then right one, up 7. That's how we have the 1, 3, 5, 7 approach. The pattern, the shortcut, because we are able to make an accurate graph without having the need of plotting all these x values or a calculation. We can just get the graph fast. That's a good way to get things done quickly. And since the square root of x is the inverse of x, okay, and by the way, a couple of days ago, I made a huge point that you should know a pair of inverse functions. They are x squared and square root of x because they are the functions that will cancel out each other. Okay, again, that's the idea of inverse functions. They can cancel out each other. Okay, so what we do? Well, we swap the x and y, right? And we will swap the way we count. So instead of going right one up 1, right one up 3, right one up 5, we are now going to be right one up 1, right 3 up 1, right 5 up 1, right 7 up 1. So that's why if you knew how to do x squared graph, it is just a little tweak. And then you have your square root function. And this is your positive square root. It's not the full parabola, it's just the top half. Okay, if you want to draw the bottom half, that will be the negative square root. Okay, that will be the negative square root. And the equation would look something like this, which is somewhat similar to your quadratic vertex form. You still have your h and k. That will be your quote unquote vertex, but it's not really the vertex, it's just a starting point. Okay, originally it will be at 0, 0. And you have your a value, you have your b value, just like what we did before. You know, a is for the vertical compression or vertical stretch, and b is for the horizontal stretch or horizontal strength. And don't forget, remember what we do with the b value? It's always 1 over b. Remember, when we interpret it, it's always 1 over b. Now, but that's one thing I forgot to put in here, and I want you to write this on your paper as well. I forgot to put down what happens when a is negative. If a is negative, what's going to happen? It's a reflection over the x-axis, like a vertical reflection, because the y value would directly change from positive to negative. Okay, so that's why it's a reflection over the x-axis if a is negative. And if b, oh, by the way, hold on. Let me go ahead and give you a little quick sketch too. So, so typically the graph goes to the right and it goes up, right? But now if it flips over the x-axis, that means the graph is going to look like this. It's going to go down and right. And that's what happens when it has a vertical reflection over the x-axis. And if b is negative, now we never really mentioned about b being negative in the past, because the functions that we have learned so far, it was x squared, quadratic equations. We have the absolute value equation, the V-shaped graph, if you still remember. All right. Those two, they're symmetrical to the y-axis. So if it's negative, it doesn't really make an impact. But this time, it's going to have an impact because the negative b value, it means it's a reflection over the y-axis. And that means the graph, it's going to go to the left. Okay, so it's going to be a reflection over the y-axis. So it's going to the left rather than going to the right. So this is how you use these information to analyze what these graphs are going to be. Okay, and down below we're going to do some writing of transformations, and to make life easier. Okay, and helps you and to help you gain confidence, I gave you the equation and also the picture, so that you can see how they go hand in hand together, and go hand in hand together and find out the transformations. Okay, so for the next couple of minutes, we are going to look at the transformations right here.